Hello everyone, I'm Mr. Hu from Heron High School teaching pre-calculus. I will also be working with you this year along with Miss Adkin, and today we're going to cover the Skill 2 notes, which is graphing functions and inverse functions. Alright, so hopefully another refresher for you all. It should not be too difficult, but we got to get the basics out of the way before we can move on to the other topics for this year. Alright, so first of all, we need to ask this question for ourselves. What is a function? Okay, many of you probably already know. Maybe you don't know how to say it exactly, but a function is simply, a relationship that relates an input x and an output y. So you've got an x, you've got a y, okay, and they work together to kind of create this picture. Okay, I'm sure many of you have seen the graphs of a function, maybe linear, quadratic, all that other good stuff. We will get to the examples in just a sec. But we also need to know that y, sometimes we call it by f of x. So not to make it super confusing or anything, but f of x and y are basically the same term. Okay, so let's talk about a couple of examples of functions. What do they look like, right, in the symbol form? From the last lesson, we talked about parent functions, and pretty much all of the functions there, such as y equals x, y equals square root of x. Okay, we got a bunch of other stuff like y equals, absolute value of x. Those are all types of functions. We did talk about it a little bit without really defining what the function is, but I'm going to formally define it for you now, so that way we can move forward that way. So if these are all functions, then you might be wondering, well, then what's not a function? What is a non-example of a function? So let's talk about non-examples of a function here. Talk about a couple non-examples of functions. The easiest way to kind of determine whether a graph is a function or not is to do the vertical line test. If you remember what that is, we will talk about it in a little bit once we get to the graphs, but the easiest example to talk about in terms of the symbols is something like x equals 1. Okay, for x equals 1, you get to the point on the x-axis where x equals 1, and the y isn't really specified, but it's the whole y up and down. Okay, kind of up and down there. And since you have multiple y's, it fails the vertical line test, is not a function. Okay, a couple of other examples are things like x equals y squared. Okay, that will give you kind of this sideways parabola, which also fails the vertical line test. And there are a couple of other ones, especially like piecewise functions, but those are the two easiest examples we'll talk about now. And I will take you to the graph so you can see what I'm talking about. Okay, here we are on Desmos. Now, I've already kind of plugged it in for you here, but this is one of the non-examples I showed earlier. And as you can see, it's a parabola on its side, but it fails the vertical line test. If you run a vertical line, okay, which I unfortunately am not able to draw at the moment, if you run a vertical line through here, okay, it passes more than once, and that means not a function. All right. We will talk a little bit more about graphs when we get to actually graphing functions, which is definitely the main point of the lesson. So let's head back to the notes real quick and let's talk about graphing functions. So here we have Desmos again, and I've got the table all ready so we can get graphing a little bit. So for the purpose of this lesson, I'm only going to be working with linear. That is the type of function that Delta Math is working with on these skill sets that I want you guys to take away from this lesson. So we will talk about the higher level functions, things like quadratic and polynomial, at a later time, but now is not that time. So hopefully that's fine with you guys. But if you want to, graph, the best, or I guess most universal way, is to kind of plug in some values for x and get the points out. So you just pick points that are probably on the graph. This might be familiar to you. We got 0, okay, 3 times 0, okay, plus 1 is 1, right? And then if you put in some other values like 1, we got 4, 3 times 1 is 3, plus 1 is 4, 2, okay, and you can even go backwards. You can even do -1, right? You can even do -2, and you should kind of see a pattern starting here. Those should probably go above those, but I added them a little too late. Okay, but they make a pattern because this is linear, okay, and you might remember that pattern, that constant gain, rise over run, is the slope. All right, so let me reveal the graph to you guys. All right, there it is. Doesn't it look beautiful? All right, So that's one of the easiest ways to, graph any function. It doesn't apply to just linear. You can always use this table method. You just have to make sure when you graph a different higher level function that it matches the shape. Now for the assignment, you guys only have to worry about the linear because again, that's what Delta Math uses, okay? So that is, in a nutshell, how to graph functions with a table of values, all right guys? So back here, I have cut out the actual symbols of the graph, like the equation for the function. And so this is for all of you who may have forgotten how to find slope from a line or what slope really means. Slope is just how we define the rise over the run, the change in y over the change in x. So what's nice about Desmos is that you can kind of pick out points on your function no matter what you put in there. So for example, I have this 0 and 1 definitely right here, okay? And then, I got this point, but that's going to be a little hard to think about in terms of rise and run. I think I'll go with this 4, -2 point, okay? 4, -2, all right? So if I've got 4, -2, and 0, 1, the change in y, how much I had to go up and down to get to that new point, is a net change of -3. I'm going downwards, right? So that's -3 on the top, and then, left to right, I have a positive gain of 4. So -3 over +4, that is a slope of -3/4, all right? The actual equation for this line is f of x equals -3/4 x plus 1, okay? I will show that very briefly in just a second. And there it is. So there's the Desmos screen fully unveiled for you. And this is the exact same graph as it was in the example. You can double check as well if you doubt my ability to kind of put the graph into Desmos, all right? Okay, so let's go ahead and kind of elaborate on this graphing idea a little more. Okay, with Desmos and with a lot of many other tools, there's a very, very neat function, okay, as long as you have the general form, okay, of the function at hand. So we're talking about linear. You guys should remember the formula mx plus b, okay? But here I've kind of turned them into sliders, so you can actually play around with the values. So let's say in your IP that you run across the equation y equals 2x plus 5. Okay, and I'm going to turn that off for a sec. Okay, let's say you run into that. Well, you can always mess with the slider to change m to be 2. That is what it is down there, and b to be 5. Right, that is what this one is. And so it will actually alter the graph in real time, okay, to fit the kind of graph you need to put together, okay? And Delta Math will kind of, guide you along the way of how to graph that, so I don't think there will be too much problem. But again, if this is stuff that you think is way below your current level, then that's great, okay? That means you're thinking about it, or you're already recalling these methods that we can use as foundations when we move to the higher level equations, okay, the higher level functions, right? So if this is something you still struggle with, I do encourage you to kind of mess around with the Desmos, especially with this general form idea. When you're doing your IP on Delta Math, that can definitely help you go a long way, all right? All right, so now let's go ahead and move to the second part of our lesson today. It's about inverse functions. Now, if you recall, you probably talked a little bit about this, but if you didn't, basically what an inverse function is you take any function's inputs and you switch them with the outputs. What I mean by that is that if you have, a table of values that looks something like this, right, with the x's on the left and the y's on the right, what will happen if you invert the function, okay, is that all the values on the left become y's and all the values on the right become x's. And that is how I draw my x's. Please don't judge me for my terrible x, okay? All right, so for example, if this had a value of 0 and 1, 2, 3, 4, 5, something along those lines, well, these would still be the same values, okay? But the value attached to them, the variable attached to them is now flipped, okay? So now your outputs have become your inputs, and your inputs have become your outputs. That's what we mean by inverse function. Let's go ahead and take it to Desmos and see if we can kind of, see it visually. Okay, and I'm back here with the Desmos. I'm going to keep using that 2x plus 5 example from the last part. Okay, and I also made a table of values, so I kind of already have graphed this. Okay, make sure to refer back to that if you need more time to kind of get through that topic. But here we have our function 2x plus 5, and I want to invert this function. I want to draw the inverse. I want to graph the inverse. So how can I do that? Well, like I said, you have to switch the x's and the y's. In this case, it's x and f of x. Okay, same difference, right? So if I'm thinking about it, this was the point -2, 1, the ordered pair -2, 1 on this function, this particular function. So in order to reverse it, I would plot a point 1, -2, right? Okay, so here's a point on my inverse. Okay, and I'm going to keep going. So this next one will be 3, -1. Okay, so what I'm doing is I'm taking the y values and putting them in front instead of behind. Okay, then we have 5, 0. We can kind of start to see a shape take place. Okay, we have, let's scroll up, 7 and 1, and finally we have 9 and 2. I do believe that was the last one. Okay, so you can see the points now are kind of creating a line. Okay, so what you can do here is you can use your knowledge of slope, okay, to figure out that going from 5, 0 to 7, 1, I'm going up 1 over 2. Excuse me. Sorry. Rise of 1, run of 2, right? Just like that. And so we know the slope will be 1 over 2, 1/2. Then we take a look at our y-axis here to figure out our y-intercept. Remember, rise of 1, fall of 2, which means we should encounter something along the lines of, I count here, it's 1, -2, right? So I should hit something like -1, -4. Okay, not -4. Looks like it's -3. Okay, that's better. My mistake there. So that line still looks correct to me. Okay, which means right here, it looks like 0 and -2.5. 0 and -2.5. All right. So with a slope of 1 over 2 and a y-intercept of -2.5, I believe I can write this equation. Y equals 1.5 x minus 2.5. Okay, or you can say 2.5. That's fine too. Okay, and I know my picture is cutting through it, but I mean I can move this around, and you can definitely see that line I just built with just the points and the slope and this y-intercept created this nice line. Okay, and I know we're probably not going to be super on top of it. Might be a little rusty on this topic, but definitely try to mess around with delta math. Okay, in order to try that, or mess around with Desmos while you do it. Okay, ask us for help if you do need it for the inverses. That's pretty much all you need to know about graphing inverses, but there is another trick. Okay, I'm gonna go ahead and put this other line here. Okay, doesn't really have anything to do with the two lines I just put up there, but it kind of is pretty interesting, right? You might have also learned this if you talked about inverses in a previous class, but I'm putting the line y equals x, the parent function for the linear equations, on Desmos. Now, what you might notice is that the original line I was messing with, y equals 2x plus 5, or f of x equals 2x plus 5, versus the new y equals 1/2x minus 2.5, okay, is that it reflects, okay, it reflects over this line. So another way to describe inverses is you just reflect what you're seeing, okay, in this line. Okay, it won't really matter what kind of graph it is, okay, but when you invert, you're always reflecting over this line y equals x, that parent function for the linear equation. Okay, that is about it for the Desmos, and I will get back to the main screen and finish up for you guys. Alright, and just to wrap up today's lesson, or video lesson I suppose, some takeaways, okay? The main takeaways I wanted you to get from this video, okay? Can you define a function, okay? That means, can you identify what makes a function different from a non-function? Can you identify one in the graph, right? Those kinds of questions, all right? As well as recognizing slope and intercepts for linear functions. I think those are very important moving forward, as if when we talk about the higher order functions, you will find that this basis of identifying features of this type of function will carry over as well, okay? And then the last point here, we have a couple of different parts of it. We have graphing functions, inverses using tables, which is the more important part. That is the part that Delta Math likes to use, okay? So I would say focus on that if you have to focus on, a different graphing method. But also in double asterisk, graphing functions and inverses by other methods. I showed a couple of those. You can always talk to me or Ms. Atkin about, how you approach graphing the inverses in Delta Math, since they're very flexible, okay? And I know there will be plenty of questions about the inverses, because that's usually, a little confusing. Sometimes you think, well, maybe I just, flip it over, I reflect it or something like that, but it has to be a very specific way, okay? So that double asterisk is kind of like the challenging part of today's lesson. So if you if you want to become better at that kind of method, and make sure you really have the mastery down, I would come talk to us in the office hours, or, talk about it in class, all right? So that's about it for today, scholars. I will catch you all on the flip side next time.